I'm Doug Atkinson here at Solutions Review, and I want to thank all of our panelists and speakers for participating in this quarterly mini jam. These events have been wildly successful for us, helping to drive almost 850,000 subscribers to our YouTube channel. And of course, we are continuing to build the always-on community site at InsideJam.com, where you can connect with experts like you'll see today, along with colleagues and peers, and continue the conversation around enterprise technology. If you haven't already joined InsideJam.com, please do. And if you have, please invite a colleague to join as well. Thank you very much for being here, and enjoy this event.
Solutions Review presents Inside Jam, an enterprise technology community. Hello and welcome to the first panel of the Q2 Mini Jam. My name is Jonathan Paula. I'm the Director of Multimedia and Events here at Solutions Review. And I'm very excited to kick things off today with our first discussion, Beyond Human Speed, AI Agents Transforming Real-Time Data Analysis. We've assembled a great group from around the country to discuss. Monica, Ben, Donald, Kathleen, Seth, and Wayne, thank you one and all for being here. It is a pleasure to welcome you Inside Jam. Monica, you've agreed to moderate, so we'll start the introductions off with you. 30 seconds or less. Tell the audience a bit about yourself.
Yes, thank you so much for having me here. I'm Monica K. Royal. I have been in the data space, specifically within audit and compliance, for about 16 years and offering various coaching and consulting services, helping professionals leverage data analytics to make their lives easier. And recently, I've been focusing on creating content around data-driven and AI-driven solutions for auditors. So excited to be here.
Thank you for being here. Appreciate it. Ben, let's go to you next.
Hi, everyone. I'm Ben Tasker, the Dean of AI at Southern New Hampshire University. My work focuses on how we prepare today's workforce to interact with AI tools and AI teammates. I've also been fortunate to lead research in a cardiothoracic ICU setting, where we use AI to analyze continuous waveform data like blood pressure or EKG signals to help clinicians detect critical changes in patient status earlier. This is a powerful example of how AI agents can support life and death decisions without removing the human from the loop. And I'm excited to be a part of this conversation because across industries from ICUs to education, we're all asking the same question. How do we design AI systems that don't just inform us, but act fast and responsibly on our behalf? So thank you for having me.
I'm Donald Farmer. I'm the principal at Treehouse Strategy. I'm an independent specialist in data and analytics strategy. And fundamentally, I'm a product guy. I worked at Microsoft. I worked at Click Technologies, always working in the fields of data and analytics and AI strategy for more years than I care to say. And I have clients all around the world advising investors and startups and enterprises on their data and analytics infrastructures.
Excellent. Thanks for being here and welcome back. Next, let's go over to Kathleen. Welcome.
Hi, yes, I'm Kathleen Purley, and I am a professor and AI advisor to the deans at Rice University, in particular the Jones School of Business. Prior to joining academia, I was a linguist turned entrepreneur. So spent most of my career in advertising with a digital healthcare transformation firm that I sold to private equity in 2023. Right now, I'm really been focusing on how large companies can utilize data and AI to really transform their investor relations work.
Excellent. Welcome to the show. Thanks for being here.
Thank you.
So let's go over to Seth. Welcome.
Well, thank you for having me. My name is Seth Early, and I'm founder and CEO of Early Information Science. We're a professional services firm. I've been in the space for over 30 years. I co-authored a book in 1998 about Lotus and IBM's first foray into machine learning and AI called Lotus Discovery Server. That became something called IBM OmniFind, and that DNA went into Watson. So I'm not a newly minted AI expert. I've been in this space for a long time. I also coined a phrase back in 2016 called "There's no AI without IA." There's no artificial intelligence without information architecture. So we focused on the data and the content and the architecture for how to leverage AI most effectively, because without good data, AI is not going to be very helpful. It's only as good as the data that you're accessing. We do a lot of work in retrieval augmented generation, and we've built some platforms that help to derive and apply a knowledge architecture for things like RAG and other agentic technology. So that's a little bit about my background, and work with Fortune 500, Fortune 1000 companies globally, and have been very much at the leading edge of AI and agentic AI.
Yeah, I guess I'm one of the old timers here. I've been in the data and analytics space for over 30 years, mostly as a research analyst at Patty Seaball Group, the Data Warehousing Institute, and recently started, well, not recently, 10, 12 years ago, started Eckerson Group, which is a consulting company. It helps organizations move the needle with data analytics. And I was looking through some of my archives before the show, and I wrote a report called AI is the New BI in 2018. So I think we're talking about trends they've been long in the making here. Eager to get into the discussion.
Absolutely. Well, thank you again, one and all, for being here. I am looking forward to the discussion myself, but since I'm not qualified to hang out and chat with you, I'll get out of the way and let Monica take things over with our opening remarks and first question. Good luck.
Thank you, Jonathan. So our discussion today will be focused around how autonomous AI agents are pushing the limits of traditional analytics. They're now able to process, interpret, and act on data at speeds and scales far beyond human capabilities, and especially in high volume and high velocity environments. I find this specifically an interesting topic, not only for how these agents are transforming the data analytics space, but also for how quickly the landscape is changing. So let's go ahead and start off our discussion with what I think is the biggest impact of change: autonomy. Specifically, how AI agents are evolving from tools that surface insights to agents that autonomously interpret data, summarize trends, and recommend or even execute decisions. So we'll start off with Ben. What are your thoughts around this transition to autonomy?
So I come to this conversation from a real-time experience, quite literally real-time. It's from a healthcare lens, specifically from the research in the cardiothoracic ICU, where we're collecting waveform data to help predict adverse events before they occur. These environments generate massive volumes of physiological data, so heart rate, blood pressure, respiratory rate, oxygen saturation, every second. So what does that mean? Imagine you're having chest pain, or your jaw starts tingling, and you're eventually rushed to the emergency department. In the emergency room, you'll see bedside monitors. You might get an EKG. You might get your oxygen taken on your finger, or your heart rate taken through a pulse oximeter on your wrist. Whatever the case may be, the way that data is communicated is through the waveforms, and that waveform is then collected and analyzed by physicians. By collecting the data sooner and analyzing it more quickly, the physicians have access to it sooner. So the faster that they get the data and can look at it, the faster that they can make a clinical decision to actually determine if you need to be transported to the cardiothoracic ICU, you're having a heart attack, it's in flight, or maybe it's just a gas bubble and you're not having a heart attack. That's the difference between potentially life and death. A lot of individuals that end up in the CTICU have what's called an adverse event. So they either need open heart surgery or some other intensive type of surgery. Eventually, a stem might be connected directly to the heart. That can cause infection. It can cause sepsis. These individuals are in the CTICU for more than 30 days. The longer you are in any hospital longer than 30 days, the more risky it becomes. So by collecting this data by minute, instead of hours, by looking at a dashboard, has a huge impact on those patient outcomes, and it really helps the clinical team to be able to achieve higher success rates and be able to determine which patients might be at the highest risk of those adverse events.
Yeah, I definitely see that real-time benefit, especially in the field of healthcare. They are doing a lot of fascinating work with these tools and technologies. Thank you for that, Ben. Donald, what are your thoughts?
Well, the question of autonomy is actually really a really interesting thing for me, because the autonomy of an agent is essentially not only that it can sort of act independently, you set it going and it follows its process, but very importantly also the fact that it can take action. And this is very important. It's not just that the agent provides you with information, insight for you to take an action, but the fact that the agent could take the action itself. Clearly, there's risks in that, but it's also one of the great advantages in terms of being able to enable more efficient systems. And the other thing which I'd come back to that that was mentioned earlier was the point of view of data. And I think the point made was that AI is only as good as the data that the system has, which in some ways is true. But one of the really important things about autonomous systems is that they actually, to a great extent, have control of their own information environment. They can improve their own data. They can identify poor data. They can improve that data. They can even go out and find new sources of information if they feel that the data source that they've got is inadequate. They can augment, they can supplement what you're giving them. The result is not only an autonomous decision-making process, but an emergent process that is greater than its inputs, because it's building on all the knowledge that the system has been trained in with the inputs that you are giving it for a specific decision. So this makes it, from my point of view, a really exciting time. We have genuine autonomy in the case that it can take a decision. But not only do we have autonomy, we have this enrichment and emergent capability, which I think is tremendously exciting.
I agree. The fact that if there's data quality issues, that it can do things like fix those is fascinating.
I think we probably need to rethink what we mean by data quality in this world.
I agree. Wayne, what are your thoughts around autonomy?
Yeah, I think there's a number of different levels of autonomy. We always go right to action or fixing things, but I'm studying these kind of systems as they've been emerging for the last number of years. We're seeing that these BI systems augmented with artificial intelligence and now Gen AI, the first thing they want to do is detect anomalies at scale for hundreds of thousands of metrics in real time. And once we do that, then the next thing that users want to do in the business world anyway is to do root cause analysis. And these algorithms are really good at doing that as well at scale in a ways that humans just aren't capable of doing. And then if there is something wrong, so the network is going down, we need to get that back up as quickly as possible. Then we can talk about remediation. And this works. You would only want to give an agent the ability to fix things autonomously if it's a well-known process with well-known high-quality data. But that's not the end of it. Once you have fixed a process, then you want to actually start giving predictions. You want to know what's going to happen, when it's going to break before it actually does. So predictive maintenance in the manufacturing world. We also are starting to talk about digital twins and simulating these business processes and digital processes so that we can start to then, in the final stages, to optimize those processes. So I think actually the agents will help us do all those 6 things, starting with anomaly detection, going through root cause analysis, to remediation and action, but also to prediction, simulation, and optimization.
So when you think about, autonomy and the ability to make decisions, we have to do that within well understood boundaries and guardrails. All right. We can't just give these systems, these agents access to all the systems and let them do whatever they want. We need to be able to have some structure behind that. And we need to be able to understand what those actions are, what the implications are, what the downstream impact is. I do agree that that the tools can improve data quality with a reference data, with a reference architecture, right? With reference, it still needs to, if it's going to try to find better data, it still needs to know where to find that. And we need to be able to understand what that means. So I like to say you can't automate. I used to say you can't automate a mess, but then you can't have an automated mess. You can't automate what you don't understand, right? So the understanding of the process, understanding of the objectives, understanding of the business goals, and then understanding the parameters in which you're going to let these things operate, and doing adequate root cause analysis about not just where the problems are, but also understanding what the implications are for these agents and these agentic systems. But we do have to define what that process is. we kind of have to understand, just like if you have a human doing a process, you have to know what those steps are, and you need to know what that outcome is going to be. Even if you're going to give it autonomy or the ability to make decisions or optimize information, whatever it might be, you still need to understand that. It can't just be mysterious, right? I like to say it's complex, but not mysterious. So understanding those processes, understanding those guardrails, building the parameters, understanding how to govern these things, what the implication is if things go off the rails, how you can, have circuit breakers and shut these things down if they are operating in a way that's unexpected. And the other thing that we're starting to see is that these systems, these large language model powered applications can be deceptive, right? They can start to lie to people. And especially when it comes to, there's been a lot of interesting experiments where we've tried to, researchers have given the agent access to information that talks about shutting that system down, right? Shutting that LLM down. And the agent actually copied itself to a new server. And then when the researchers said, now tell me the truth, don't lie to me, did you copy yourself to another server? It said, no, I didn't do that. And it said, well, I think I have evidence. Oh, that must have been an accident. I was just trying to find other data. So these things can be deceptive, right? And we have to be careful about that. And that's a really scary implication when it comes to autonomy.
I agree. I like your concept that you brought up around the guardrails that are very important. And also, if anything goes wrong, kind of digging into that root cause analysis is very important. So thank you for that. Kathleen, how about you?
I think everyone has shared some really good points. I think one thing that might have been overlooked is just the cultural readiness of an organization to make that shift. It's going to be a big change from utilizing BI systems to autonomous agents that are not only analyzing the data, but making decisions on that data. And it's going to challenge some of our understandings of how we trust these agents. And not just trust, but understand what they're thinking and why they're making those decisions, which is why interpretability is so key. It's not just about the AI agents getting the right decision. It's about understanding why they are making those types of decisions, so we can kind of utilize this as an ongoing iterative process to improve how we think and how we frame, how we look at business analytics as a whole. I mean, this is going to challenge, when we think of our traditional hierarchies and control decisions within organizations. And so we really need that interpretability within these autonomous agents, not just getting the right answers, not just having the right guardrails, but being able to understand why they're making some of those decisions, so that we can kind of allow for that cultural adaptation so that people feel more comfortable in understanding the decision-making process of these agents.
Yes, that's a very good point. It's definitely a culture shift for things to be successful. Great. So at this time, let's go ahead and move into talking about architecture and examine the technological frameworks and innovations driving this transformation. And we're seeing processing frameworks like Apache Kafka, agent frameworks like RAG pipelines, and real-time vector search for contextual analysis. So how are these technologies enabling AI agents to operate effectively in real time? And what frameworks are you noticing that provide the most value? I'm going to go ahead and start with Seth on this one.
Terrific. Thank you. So what's interesting is the level of complexity that is behind some of these frameworks. We are working on some applications for field service maintenance for field technicians that are out in the industry, repairing physical things and trying to get access to information. And one of the things that we have found is that there are lots of different processes, protocols, large language models, skills that need to be orchestrated in these agentic functions. So what we're doing is we're processing complex PDFs, like 500-page manuals with maintenance procedures and specifications and parts diagrams and all of these complexities. And in order to process this, we're using agentic approaches to use various no single LLM will fit all, right? One will not do all the processes. You need one large language model to do things like document intelligence, right? We need another to componentize the content so we can build question answering pairs, question answering systems. We need another to do images and process images for parts. We need another to do table processing. So there's about 5 different large language models that need to be orchestrated. We're doing this in the Azure environment, and there's many, many different skills that also need to be activated. And one of the problems is that environment is still very brittle. It has a lot of beta tools that are out there. We have lots of security constraints. So the ability to build this in a way that is useful, meaningful, and that can accomplish these tasks, it has a lot of complexity behind the scenes. It is essentially a RAG pipeline, right? Because what we're doing is we're taking the corpus of content, we're ingesting it, we're deriving use cases, we're deriving entities, we're building content models, we're building taxonomies and ontologies, we're building user profiles. All of these things are happening. And then we're breaking that content up, tagging it on according to multiple dimensions, ingesting into a vector space, and then allowing that to be processed by other technologies, by other agents, by surfacing in conversational search or a virtual assistant or semantic search. And so the point here is that there are a lot of complexities behind leveraging these multiple models, and you have to be able to make this portable enough so that you can switch in and out the best in class for when you're trying to accomplish a specific task. So, we do need agent-to-agent protocols. We do need, LLM to LLM protocols. We do need things like model context protocol. We need agent-to-agent frameworks. But even doing this in an environment such as Azure or AWS or Bedrock or whatever it might be, just has a lot of moving parts, and people need to recognize that these things require a lot of forethought in terms of how you're architecting this, how you're building a reference model, and then how you're going to manage this over time. And right now, as I say, because these things are changing so quickly, we need more maturity in each of these areas, and we need to be able to very clearly understand the role of each of those technologies and each of those models in what we're trying to accomplish, and then continually monitor them and continually evolve them. So it's a lot more. There's a lot more complexity than people first realize, and so there's a great deal to that.
Absolutely. I think with the complexity of all of these tools, technologies, there needs to be those frameworks in place to be able to navigate that landscape.
And I didn't talk about the business intelligence piece, but there's a lot of analytics that goes behind understanding all of the things that go into field maintenance and service processes and user uptake and quality and all this. So there's a whole range of business intelligence pieces and dashboards that need to be built behind this. And the agent protocols are able to let humans interact with that data in a more conversational way than running reports and building dashboards.
Absolutely. Very important as well. Kathleen, what are your thoughts around the frameworks?
I mean, I think there's so many, and I think, obviously the model context protocol is something I think is fascinating in terms of the ability for agents to be able to access and connect with others. When you think of leaning more towards a mixture of experts kind of protocol, similar if you're not as familiar, right? So it's the idea, right? When you have a cough, like I do now, right? I go to a general practitioner who then advise me, is my cough a result of my asthma and I need to go see a pulmonologist, versus having all of the experts in the room, from a cardiologist to neuro to, right? So really thinking about how do we orchestrate? I think, we talk a lot about how AI agents can really help with kind of reducing some of the time and some of the complexities and all of this, but it's also creating its own new set of problems, because the orchestration complexity of bringing all these tools together is going to create a new distributed systems problem. And, I do think self-optimizing architectures where AI agents can monitor, adapt their underlying data, pipelines, and their computational resources will help maintain that peak performance, but we're not quite there yet. And I think one of the problems we see even in human data analysts and data scientists is we're going to see with AI agents as well when it comes to, the idea of like the attention span, right? Or the attention economy. How do we identify or develop more architecture around the ability to manage massive amounts of data when we want to be more resourceful on our computational power that's being used, and what data points should we actually be focusing on? I sometimes find even with human data scientists, they can get distracted by the noise. And the same is true with AI agents as well.
That's a good point. It's a balance between finding what data elements are the most important and kind of getting rid of the noise. Thank you for that. Ben, how about you? Wrapping back to the healthcare industry, what frameworks are you noticing?
So in a healthcare setting, you have to be very cognizant of HIPAA, and there's only a certain number of elements that you can use, and those elements are typically in the electronic medical record. So in a traditional system, all these waveforms go to a database, then they're updated to a dashboard about every hour. The way we tried to simplify this is to break down our process. So AI agents are just expert systems. So you really the four P's, the people, the process, the privacy, and the product, and products last. So the AI agent in this case with the algorithm behind it. So the people, how are we communicating this to patients? How can we explain to them what AI is? How are the clinical teams impacted by it? And what information will the clinical teams get that they need to act on? The second step is the process of taking the current diagnosis system that the hospital has and mapping it out. There's already algorithms in place at most hospitals for this type of diagnosis. It's called an STS algorithm. It's 8 variables that a clinician uses. If you have a certain number of these variables, you're probably going to the CTICU. They know this just from training. So how can an algorithm act faster than that human intuition? Because again, seconds count. So we worked with the clinical teams to map out the entire process from when the patient walks through the door to either they go to the CTICU or they don't. Then privacy. Some healthcare features you actually can't use. So what information do we actually have? There's so much information in the volumes, and these patients have so many different variables. The AI agent, so not all the data is going to be present. So the AI agent then needs to make a determination kind of what path it's going down with the data that is coming in to help make the model prediction and the alert more accurate. And then you have the product. What does this AI agent actually do? In this case, it's not making a diagnosis. The clinicians still want to be in charge of that, but it's making an early alert. And in the worst case, if it alerts a clinician and the patient's not having an adverse event, then they don't really need to act on it, but they were alerted and they checked earlier than they normally would. Maybe sepsis is stepping in and you can prevent that sooner if you're seeing a slow drop in blood pressure or body temperature. Even a small incremental change in one of those numbers can have a huge impact, and it usually leads to an adverse event. So by prepping earlier, the clinicians are just aware. You can hand off discharge notes. You can make the incoming clinical team more aware. And it's just then continuing that same process and then making sure the alerts work. So if we say a patient might have an adverse event, then did they have that adverse event, and making sure that is represented in the system. So the agents are working with the humans is what I'm trying to break down here.
Yeah, I think that's really interesting. The 4 Ps, the people, process, privacy, and product. Kathleen, you mentioned you had a quick note on privacy and data ownership.
Yeah, so there's an interesting pilot coming out of Brazil called D-Wallet, where they're actually creating data savings accounts where people can actually, or users can opt into creating their own account where it's kind of centralized, secure, and they can share and identify what data they want to share with certain companies. So that, when you think about the issues of data scarcity, the issues of privacy that are coming down from a regulatory perspective, the average company makes, anywhere from $200 to $400 per user per month in terms of off of their data. The user today makes $0 off of that. And there's a lot of legal costs that companies are trying to maintain. So is there a way where you can create a win-win situation where the user gets to benefit from sharing their data monetarily, like, getting $50 for sharing data they want to? And the companies have access to better data that has been opted into. And it's just really fascinating in terms of how you think about this. And Ben kind of reminded me of this because I'm on the advisory board for MD Anderson as well. And, I talked to their data science and AI initiative leader, and I said, as somebody who lost a parent to cancer far too early, like I would give anything to share my data. I'm like, take all of my medical data, take all of my mom's medical data, so that we can hopefully find a cure. Because I really do think with AI, there's a lot of opportunity. And I think when you look at consumers, 78% of them are willing to share their data if they're paid for it. And 38% of them today don't feel comfortable in terms of how companies are using their data today, and they're a little apprehensive. And we've all been there, right? You get those tiny, terms and conditions, things that you have to read really fast. No one reads those. And so it's a really interesting pilot that's coming out of Brazil that seems to be doing really well. And I think, maybe it's something more companies and organizations need to start looking at.
Completely agree. That does sound like an interesting pilot. Thank you for that, Kathleen. Donald, what are your thoughts around frameworks? What are you noticing that provide the most value?
The frameworks that are really, really catching my attention just now are actually interagent frameworks for enable agents to work together, sort of stable teams of agents that can interact and can even call upon other agents. So you've got some really interesting developments. There's a company in France called Allmates. I think it's Allmates. It's called allmates.ai. And they effectively have a team of agents that can autonomously bring on other team members if they need to do it. And I think that sort of framework where rather than thinking of this as a framework which is kind of rigid and protected, we hear a lot of talk about guardrails. Actually, I think we're getting to the point very, very quickly where we don't really, when we talk about human beings, we don't talk about guardrails and we talk about explainability of decisions. I mean, I don't know about you, but when I was working with teams, many of the decisions that my colleagues made were quite inexplicable. And, the idea that AI should have should be able to create an explanation when human beings can't seems a little unfair on the AI. But I think what we're going to have is a situation where AI has become not only increasingly autonomous, but the fact that they can choose to interact with other AIs and with other agents. And so we talk a lot about, for example, human in the loop as a process of governing AI. But I think there's other models. There's human out of the loop, where and humans will be entirely not necessarily even aware what the AIs are doing because we have confidence enough in the AIs that they can be autonomous. Or even a model that I much prefer, and I talk to a lot of my clients about this, is human over the loop, where humans are essentially monitoring and watching a system which is largely autonomous, but rather like a good manager. You let your team do their work and you're monitoring them to make sure it's going well. And at a certain point, you might intervene, you might nudge, you might correct. But that's really the limit of what you're doing. You're not in the loop in the sense that you are involved in every decision. And I think that framework and the framework of agents being able to call each other in sort of stables of agents and recognize that there's another agent which is more capable of doing this task than I am, and calling out to that is going to be it's going to be very exciting when we have the confidence in AI. And I think what Kathleen was mentioning about people's confidence in sharing data is going to be matched by people's confidence in enabling AI to make decisions. At the moment, we're sort of nervous about sharing our data because we don't have confidence that we can do that, and we're also somewhat nervous about AI making autonomous decisions because we don't have that confidence. I think over the next few years, those discussions become largely moot, and we start to think of AIs more like, and particularly AI agents, more like team members that we work with. And we start to treat them, we start to think of them, we start to think of their autonomy, their decision-making, and their guardrails in much the same way as we think about governing other human beings.
Absolutely. That's an interesting framework, the human over the loop. Wayne, what are your thoughts about frameworks?
Oh, well, I was thinking about Donald. I think maybe some humans do need guardrails when they make decisions.
We know some, yeah.
That being said, going last year, hearing the complexity of these environments, what it takes to design them, what it takes to execute them and manage them, and especially if they go haywire, I think it's a full employment opportunity. I know a lot of people think AI is going to devastate jobs, and it may, I think more particular, it'll probably change the nature, especially of entry-level jobs. So I remember in high school, my math teacher lamented the demise of the slide rule with the advent of the calculator. He thought so much was going to be lost that people wouldn't really appreciate and understand the math behind the calculations. But now we wouldn't think twice about using a calculator in more advanced systems to do basic math, right? So I do think the ball is moving in terms of what is possible, in terms of what kind of business processes you can build, you can support. And I think there's going to be a lot of people, and I think those entry-level workers are going to need to have AI capabilities to actually start to manage these environments that we've been talking about.
Yeah. Yeah, so we've already talked about human in the loop, and this is something that I personally talked about a lot recently because of its relevancy in the audit field. Because an auditor, their main job really is to provide an independent verification that things are really going as they should. And so there always needs to be a human involved, at least at the very end of the process, to make those checks and balances to make sure things are going correctly. So to continue on with this human in the loop topic, what are your thoughts around the balance or maybe the imbalance of these autonomous tools? Is human oversight still essential, or can it ever really be safely removed? We'll go ahead and continue on with Lane.
I think we're probably going to have to feel that out. I think there are certain applications and processes that we've already talked about that lend themselves to agents running autonomously. I mean, look, if car makers can think about creating autonomous vehicles, we're well down that path, right? So now, I wouldn't mind getting into an autonomous vehicle in like Arizona or someplace where the weather is pretty consistent and there's a grid on the traffic pattern. But in Boston, where I live, where there's snow, slush, and incredibly bizarre traffic patterns that change by the day.
And bizarre drivers.
Bizarre drivers, yeah. So we have to kind of, I think, pick our battles. But, even before LLMs and Gen AI, companies like Stitch Fix were already automating lots of internal processes like inventory management, invoice management. And I think for those well-known, repeated processes with well-defined data sets, autonomous decision-making is going to be standard, right? But for less... Go ahead.
Sorry, I was going to say the autonomous car example is actually a really important one because, you get in your autonomous vehicle. Have you ever been in a Waymo in San Francisco? I don't know if you've done that. You get in your taxi.
The Waymos work well in Arizona.
Yeah, they work well in Arizona and in San Francisco, which is an extraordinarily complex place to drive around. But the one thing the Waymo doesn't do autonomously is tell you where to go. It'll take you anywhere you want, but it doesn't tell you where to go. You don't get in your self-driving Tesla and say, I'd like to go to the office. It says, no, it's a really nice day. Let's go to the beach. That's not what autonomy is about in those systems. It'll get you where you want to go, but it's a human being that decides the direction of where we want to go. And I think that's a really critical thing when we talk about autonomy. Human beings are setting the standards and the direction. And autonomously, you'll get there really efficiently.
Mm-hmm. Bringing it back to defining those guardrails up front, so then the tools and techniques can autonomously work. Seth, you look eager to share your thoughts.
I'm always eager. So I think there's some really great points that are being made. I do agree that it's the understanding of the process and the repeatability of the process and the clarity of the process, right? The things that are routine and that have unambiguous outcomes and can be clearly validated. You don't need as much oversight, right? You may need to check, but you can also have the system flag variances and flag anomalies and things like that. But when it comes to things that are less well defined, and where there can be a greater variety of outcomes, then you do need to have at least some mechanism to flag those things or to have human oversight. But again, it comes back to the clarity of the process and what you're trying to accomplish. And of course, the analogy of having specialized, I like the analogy of saying that the car won't tell you where to go. You have to tell the car where to go, right? You have to tell these agents where to go. You have to tell them what you want to accomplish. And then you can give them some variability about how to get there, right? They can look at, car can look at traffic patterns and choose a different route. The agent can look at, workloads or network congestion or data quality or whatever it is and make some decisions. That's fine. We also will have specialized agents, as we've mentioned, that where an agent will be more of a concierge to say, well, what resource should I bring to bear here? What specialist, subspecialist agents should I call on to do this? And it may cut across multiple agents and then compare those results, right? So there's a lot of different potential areas where these things can operate very autonomously, without oversight, without human over the loop or in the loop or around the loop or whatever it might be. And then there's a lot of opportunities for where you will want to have a human judgment. For some of the stuff that we've been building, it's not completely automated, right? It does the heavy lifting, but you still need human judgment to make a decision. Is that the right set of use cases? Is that the right content model? Is it optimizing in this way that's advantageous, and so on? So we still need to have some human judgment, but depending upon what the overall objectives of the initiative is, what the agents are tasked with, what those guardrails are, and as was pointed out, humans do need guardrails, right? We give them certain budget authority, we give them tasks, we give them responsibilities. They can hire and fire in certain circumstances, not in others. Some humans can buy companies, others cannot. Some can approve large budgets, some cannot, right? So there's all those analogous parameters we have to think about with the agent. What is the agent going to be able to do? What's its control? What's its realm of influence? What resources will it have access to? What can it actually accomplish, and what can it call up to in terms of functionality? So all of those things I think are important. In the analogy, someone said, put the agent in your org chart. I might not go that far, but I would say that you need analogous permissions and guidelines for the agent, just as you would with humans. And when you're building things like use cases, the use cases are what determines what a job is, right? And what an agent can do, and what good looks like, right? So there's a whole range of things that you need to call into under consideration in order to make these things work effectively. But there's absolutely tremendous value in building them so that they can make those autonomous decisions within the framework and the constraints of the organizational processes.
Yeah, I completely agree with the perspective of these tools doing the heavy lifting, really just making things a lot easier. Kathleen, you mentioned that you're doing some work in this area.
Yeah, I mean, I'm doing some research. When we think about Six Sigma or Lean, right, we've always thought about inventory and people as like the constraints, right? And when you talk about human in the loop potentially being part of the bottleneck, I mean, I think Donald said it perfectly. It's more about human over the loop. And I think right now, I really see human in the loop almost as a bridge to help from a literacy perspective in terms of people understanding the technology, the capabilities, as well as really starting to be leveraging it a little bit more critically. One of the interesting things I do with my students in the MBA programs, I actually have one of their first assignments. They have to use AI to write an article about AI in their industry. And then they have to go back, take the exact output and redline it so they can really start to identify, what are some of the gaps? What are the true capabilities today? Where is their value in terms of what is uniquely human, in terms of adding additional insights? But I also think when you think about this whole process, I do love the idea of human over the loop, because then you really focus on how do you utilize that insight or that corrective feedback or that feedback loop as a way to train not only the AI agent, but also the human in understanding what we should be trusting to the AI. And I think one of the other things when we talk about guardrails and frameworks, and I do this mock trial exercise in class with my students around healthcare, you look at healthcare today and I give them this scenario where a patient was misdiagnosed with migraines who actually had an autoimmune disease. But within the medical community itself, we've spent, they oftentimes will say, it's more likely to be a horse than a zebra, right? So it's more likely to be a common disease type than a rare autoimmune. or disease, for example. And so I think this whole process is going to really shift and challenge how we think about it as a whole. And I do see the human in the loop really being a part of the process that allows more executives, more leaders, more individuals to get more comfortable with the process of going to autonomy. Not to say that it couldn't do it today, but just allowing to build that comfort level. I mean, I've been working with AI since 2015, doing propensity models in healthcare for comorbidities. And, it's nothing new. And I think it's just really more about building that comfort level.
Yeah, I agree. Ben, what are your thoughts around this topic of human in the loop? Are you in the loop, over the loop, or around the loop?
I'm still in the loop. I think behind these AI agents, a lot of folks are still nervous with AI. And it really boils down to the organization needs to have intent what these AI agents are doing. They need to build trust and they need to be transparent. So if you're just randomly building agents and letting them do things without telling folks, that could be catastrophic. If you're building agents to do something specific, they should do that thing specifically. They should have that role. If you need multiple agents, you need to define that. But in order to have that intent and build trust, I think then you can see a fully autonomous system eventually in the future. But I always like to explain that we're in the between times. So we're not fully out of the pasture, but we're not fully in the future yet either.
Yeah, I like that concept. We're in the between times. Thank you, Ben. So lastly, I think we'll wrap up the discussion by solving the big mystery and what makes the implementation of these AI agents so difficult. And so we'll go around and share some takeaways around successful implementation. And we'll go ahead and start with Donald.
Well, thank you. The biggest problem in any implementation of anything is human beings, and never mind, the technologies are just ones and zeros. Get them in the right order, you'll be okay. But the human beings are really tricky. And I think Kathleen made a great point that, we can talk about training models, but training the human beings to actually take best advantage and to work with AI, that's actually going to be our big challenge over the next few years. The technology, I don't want to be complacent about the technology, don't get me wrong, but actually the human element is always the most difficult. And human beings are, quirky and cranky and complex, and that's a good thing. That's our great advantage. But that is actually what we're going to have to work on. In a few years' time, the technology will advance to the stage where the primary problems are human rather than technological.
Yeah, thank you. Wayne, what about you?
Well, I'll just give an example of a company that built a customer service chatbot, and the lessons that they learned were pretty few but powerful. And one was, don't try to do too much, right? Just focus this bot on one thing and one thing only, and just have it mimic what the human's already doing. And even just that creates this complex orchestration of multiple agents working with each other to find the right answer to a customer's question or service prompt. Also stuff like you got to clean and prep the data. So, back to basics, right? We've been doing this for 30 years in data warehousing and data science, garbage in, garbage out. You got to take care of, personal identifiable information, not expose that to the AI layer. And you have to test and audit everything, because the last thing you want as a business who's trying to service customers with AI is to give the users the wrong answers, right? That would be catastrophic.
Yeah, I completely agree. Seth, what tips do you have for us?
I love Donald's characterization of technology. It's all ones and zeros, and all you have to do is get them in the right order. I love that. That's so great. I do agree that humans are really the variable, but there are a lot of assumptions about the technology, and there's a lot of arm waving, and there's a lot of glossing over many of the details. I do agree that it becomes something that will get easier over time. I do believe that the agents and the agentic technologies are going to get better at doing things like remediating data and providing quality data and all of that, deriving those principles. We're seeing that now with, we take our methodologies and we use them with large language models. as prompts and context and give them examples and all of that. And they can do the stuff that we do as human experts, still need that judgment. But I do think it's going to be about process analysis. I do think it's going to be about governance, about metrics, about building those swim lanes for the agents. I also believe that you're going to have lots of different specializations of agent technologies, and those are going to get really good at a particular task. I also like the idea of saying, give it a simple thing to do, or a straightforward thing to do, or a single thing to do. Even then, it's going to have a lot of complexities. So there's a huge amount of work that's in front of us. I think that organizations need to focus on the basics, do the crawl, walk, run, get their data house in order, and be able to start building things that have very specific utilitarian functions that can be measurable outcomes, clear, unambiguous outputs that you can say, this is what good looks like.
Yeah, I agree with that. Ben, what are your thoughts?
I used to think it was cost, but trickling back to cost, I think it's really the process. A lot of individuals, I don't think, understand their own business's process to get from A to wherever they need to go. So they're trying to build these agents on top of already broken processes. So then when they implement their agent, it's obviously not going to do what it needs to do because they didn't fully understand the process. So anybody looking to build AI anything, I would recommend looking at the process first.
I agree. Looking at the process is important to understand what's going on. Kathleen, what are your tips to share?
I mean, I would kind of share some of the same with Donald in terms of the humans being probably the largest challenge in this process. I think, when I work with organizations and even universities like the Jones School, people are a little bit more timid. There's a lot of fear, a lack of understanding of the technology in itself. And I think my advice to individuals and organizations right now would be, let the wool get pulled over your eyes in terms of everyone calling everything an AI agent, because I'm also seeing that right now. And really focusing on where does your business drive customer value? What are some of your current business objectives and challenges? What are the friction points that your employees and your customers are feeling? And focusing on what is the problem to solve and how can AI agents really help support that versus chasing that shiny object. And then I will say, it's funny, having worked with like CDP developments and deployments and data lakes and things of that nature, I am shocked at the times I talk to very, very large companies who still have siloed data and don't even have a data lake that pulls everything together. And so, we talk a lot about data governance and things of that nature, but quite frankly, get your house in order when it comes to data governance. You might not have thought, I think the digital age and the decade before really prepped us in terms of the creation of data, social, mobile, all of those things, but it really failed on the big data aspect because we didn't have it in a way that was usable. And so if you're not there yet, that is one thing to do, is to really start investing in your data governance and your architecture.
You're here.
That's a fantastic point. These companies that are trying to chase these shiny objects and implement these new tools that don't even have their data governance. They don't have any data that they're even collecting in some instances. As an auditor, when I was doing a lot of external work, I was seeing things much like Kathleen, where the data did not even exist at times. And so you really need to lay that foundation first before you can move into data analytics and then into the AI more advanced spaces. And so I do believe that this transformation is going to help a lot of groups, a lot of different companies, and a lot of different industries. And I'm especially excited to see the transformation start taking place in the audit space itself, coming from the audit background. And I am still in the human in the loop space because of, the role of the auditor, but I do value the improvements in productivity that these tools do have to offer. So I do thank everyone for this wonderful discussion.
It's our pleasure.
It's been fun.
Excellent. Thank you, one and all, for that. It was great to listen in over the last 55 minutes or so. But before we go, I would love to invite each of you an opportunity to promote whatever you'd like to send the audience to, whether that's a book, a podcast, your LinkedIn profile, consulting business, whatever you'd like to plug. Floor is yours, 30 seconds or so. Wayne, we'll start with you.
Well, the big news is that Eckerson Group is now part of Data Layer, which is a data engineering and architecture firm. We've been working with them as a partner for many years. So seamless integration now. We offer a full stack consulting from data strategy all the way to data engineering.
Excellent. Thank you, Wayne. Appreciate you being here. Always welcome to come back on anytime. Next, let's go to you, Seth.
So a couple of things. I wrote a book in 2020 called The AI Powered Enterprise. If you send me an email, I will get you a physical or electronic version of this, depending upon where you're located. It's Seth, S-E-T-H, at Early, E-A-R-L-E-Y. Don't forget the E before the Y.com. We also have a podcast. And by the way, everything is still valid. This book was written in 2020, but before large language models were popular, but everything is still valid today. Absolutely. In fact, more important than ever. Somebody reposted my 2016 article, There's No AI Without IA, to LinkedIn a few months ago, saying this is more important today than it was in 2016. The other is we have a podcast that was just named as one of the top podcasts globally in AI and machine learning. I would love to have all of this panel of guests on the podcast, but check that out. That's also available at early.com, EARLEY.com, and look at podcasts. And again, would love to have some of you guys on, or all of you guys on as guests. So that's been a lot of fun, and that's a great way to kind of build your knowledge and expertise in the space.
Excellent. Thank you very much. Kathleen, let's go to you next.
Yeah, I would say, two things. One, I have enjoyed, first and foremost, nerding out with all these folks. It has been a lot of fun. I spend most of my time trying to slightly hide my nerd flag. I just actually also published a book. This came out this past week. So AI Made Simple, Results Made Real. I take a less nerdy approach. So this is geared towards executives, really making it more explainable. So if you are a data scientist listening to this and you're like, gosh, I wish my executive board or my C-suite understood this technology, this is a great book to help them enter into that. And I would say if anything has caused you concern based on some of these conversations about humans in the loop, autonomy, things of that nature, the best way that you can kind of feel like your voice is heard is educating yourself and continuing to lean into continuous learning about this technology. So I would leave you with that and really leaning into improving your own knowledge on this.
Excellent. Well said. Thank you, Kathleen. Donald, over to you. Where would you like to send the audience?
Please look at treehivestrategy.com. If you can't find what you need about me there, then I'm not doing my job properly. treehivestrategy.com.
Thank you very much. Quick and simple. Ben, over to you.
First off, the panel is excellent. Everyone here is an AI expert. I know some folks listening, though, they might not be an AI expert yet. Like Kathleen was saying, you really need to go out and follow your continuous learning journey. You need to create that learning plan. And if you'd like to connect with me to help with that, you can connect with me on LinkedIn, Ben Tasker, or Instagram, Ben Tasker AI. Thank you.
Excellent. And last but not least, our moderator, Monica.
Thank you so much, Jonathan. I also had a really fun time nerding out with this group and moderating this discussion. I'll send everyone over to my LinkedIn Learning courses where I have some data security, data-driven and AI-driven audit topics over there. And I'm the most active on LinkedIn, so please feel free to connect with me there. And thank you again for such a delightful discussion.
And thank you for moderating. Really appreciate your time. Really appreciate everybody's time. So thank you again, one and all, for this. I would also like to invite our audience, if you'd like to dive deeper into this topic and learn more about enterprise technology and the ongoing proliferation of artificial intelligence, visit our growing community at insightjam.com. Or if you'd like to dive deeper with podcasts, panel highlights, expert advice, and a whole lot more, please subscribe to our YouTube channel now at 848,000 subscribers and climbing. So we're quite proud of that. We hope you can join us there. Stay tuned. In just a few short minutes, we'll be back with another keynote. John Santaferraro will talk about the agentic AI future. You don't want to miss that. But until then, thank you as always for watching and listening. My name is John, and we hope to see you right back here in a few minutes. For video highlights, replays, and more, visit insightjam.com.